All right, welcome to the Unit 12 review. I posted some videos that I had previously recorded as your FRQ samples. So those are posted where I drew a perfectly competitive firm with a profit, one with a loss, and then one going from short run to long run. So you can check those out. They're all about under 4 minutes, so should be helpful to you. Now I'm going to go over the other things you could be tested over that are not that graph, but I'll talk a little bit about the graphs as well. So our first video was just over long run average total cost, or LRATC. But we know in the long run, there are no fixed costs, right? The fixed costs from our last unit were mostly just in the short run, we're talking about land, we're talking about capital, machinery, talking about building your actual physical space, physical plant, and all of those things. In the long run, you can change. I can buy more land, I can get a bigger space, I can get more machinery or less machinery, right? So even your fixed costs in the short run become variable costs in the long run, right? That's important to note here as we're looking at this. In the long run, all costs become variable. So then really we only have one cost. We have total cost. We don't have variable and fixed. Variable and fixed are all the same cost now. So they're all variable, which means that they're all a part of total cost. So instead of having multiple curves for our cost curve in the long run, we have one, and it's called long run average total cost. Okay. So as a business grows, they get advantages, right? They get to take advantages of specialization. So as I hire more people and produce more, I can be hyper specialized, right? I can have individuals that do only one specific task and do it really well. And I can even hire people who don't have necessarily a lot of training, so they're not quite as expensive for me, because I only have to train them to do one very small job. They don't have to know how to build a whole car. They just need to know how to screw in a couple of bolts. Those are very much lower skill threshold there. So as a result, the total costs are going to fall initially. Right? And as the business grows, it also gets to take advantage of mass productions. I shouldn't say production, so say mass production techniques. There we go. Mass production techniques. So now they can use things like an assembly line because it's large enough, or they can use things like bulk pricing where they buy something in huge bulks, and as a result, the cost of each individual unit falls. So for all of those reasons, initially as firms get larger, average total cost falls. That's right here. This is our range number one. We call this the economies of scale. It's the idea that initially as a business grows, they take advantage of mass production techniques and specialization that have lower average total costs as they get larger and larger, right? But in the long run, eventually they'll hit the second tier. We call this constant returns to scale. What this means is you pretty much bottomed out. You're at the lowest possible average total cost. And this normally is because there are limits, right? The firms I'm buying my resources from, they have to maintain profitability, so they can't sell it for any lower to you. So that's a minimum there. The people I'm hiring, there's a minimum wage. So once I get to those lower skill positions because of mass production techniques, I still have to pay them, right? I can't go below that wage floor. But as a result, I still have to pay them. And so the costs kind of bottom out. I've already experienced all the advantages I can get from new machinery and new space and things of that nature. Those are constant returns to scale. In other words, the change in total costs, the change in quantity are the same. All right, and then finally we have diseconomies of scale. Diseconomies of scale means that my average total cost is actually going up as I increase the size of my firm, right? As I'm producing more and more and more. The reason for this is because it's difficult to manage. We call these management costs start to accrue. For example, the larger your firm is, the more susceptible to lawsuits it is. So a lot of lawsuit costs can be attributed to this. When you have a huge workforce, they now have power in numbers. So they can unite, and negotiate higher wages as a result of that unionization, right? And as a result, can push those costs up. And then also we have managers over managers over managers over managers, right? The amount of positions you have to hire for can be astronomical. It can be very difficult to manage, and you start to see some inefficiencies as a result of being just too large. So in those cases, average total cost rises, right? In order to produce this final quantity, this enormous amount, it's just too expensive, right? The costs rise as a result. Okay, just a quick example of a format switch you might see is instead of seeing it in this nice, tidy little graph here, which is nice, knowing those three ranges, economies of scale, constant returns of scale, and diseconomies of scale, sometimes you'll see it like this. You're given a quantity and you're given a cost. And you're asked, what's going on here? Are we experiencing economies of scale with this growth? Are we seeing constant returns of scale or diseconomies of scale? So you need more than one data point in order to determine this. I need to know what average total cost is at point 1 and what average total cost is at point 2. And if from point 1 to point 2, average total cost is decreasing, I have economies of scale. If from point 1 to point 2, average total cost remains the same, I have constant returns of scale. If from point 1 to point 2, my average total cost is rising, then I have diseconomies of scale. Right, so check it out down here. How do you find average total cost? It's simply total cost divided by quantity. So here my total cost is 100, my quantity is 100, but my average total cost is $1, right? $1 per unit. That's what it costs on average to produce a new unit, right? But when I move to production number 2, it's $300 divided by 200. In other words, my cost is rising at a greater rate than my quantity. So now it's more than $1 per unit. So from point 1 to point 2, my average total cost has increased. Well, where am I at on this graph over here? My average total cost is increasing, then I must be at diseconomies of scale, where an increase in quantity increases my average total cost. All right, be able to show that if that price had, or that average total cost had gone down, that'd be in this range. If it was the same, if from going from here to here still was an average total cost of $1, then I'm here at constant returns of scale. All right, hope that was helpful for you, and stop.